Hi, and welcome to lesson 2.3 about scale, about using scale diagrams, how to calculate lengths using scales. Before we start doing the notes here, let's just go. I'm going to go take a picture of the Earth here. This is from Google Maps, and if you'll look way on the bottom right-hand corner, there is the scale. It says that this distance on your screen represents 1,000 kilometers on the globe. If we zoom in a whole bunch, I'm from Nelson McIntyre Collegiate in Winnipeg here, and we are talking about the scale of this. This is our school here from overhead. Now check out how this changed. The line is actually pretty close to the same size, but now instead of that length representing 1,000 kilometers, it's only representing 100 meters. Here's one more example. It's kind of 4 examples in one. Here's a map of, it looks like continental United States. 1 inch represents that many miles. 1 centimeters represents 940 kilometers. And then if they zoom in, you'll notice how the numbers change. I want to point out how it's usually 1 centimeter equals some number of kilometers and so on. And if you're doing imperial, it'll be 1 inch. So when you're doing scale, that's one thing that we can remember. So let's go back over here, take a look at it. Here's an example where scale could be 1 inch and 5 feet. And I guess there's really 3 ways we could write it. We could write it these 2 ways, like as a fraction and then as a ratio, or you could also write it as 1 inch equals 5 feet. So there's 3 different ways. Let's solve this problem here. It says a line that is 2 inches long using this scale represents how many feet in real life. So I took this scale and I made a proportion out of it. Now let's just analyze this for a second. The top, the numerator here, represents the length on the scale diagram. So for example, it could be the length on the map. The bottom part here represents the actual length. So if 1 centimeter on the scale diagram represents 5 feet in real life, what do 2 inches on the scale represent? So I set this up and we can do our old cross multiplying. We can say 1 times x, which is x, is going to be equal to 5 times 2. 5 times 2, so x is going to be equal to 10. So our answer is going to be 10 feet. So one thing when you answer these questions, please remember the units, right? The feet. That is part of the answer. You didn't have to do the cross multiplying. You could go and look at sort of like a pattern. You'd say, oh, well, 1 inch to 2 inches, I'm just multiplying times 2. So 5 times 2 could give me 10. That would work as well. If there are no units on a ratio, if it doesn't say things like inches and feet, you can assume that they are the same. So if you just were told that the scale was 2 to 10, then, for example, 2 centimeters on paper would be 10 centimeters on real life. You would just use the same unit. So let's try these examples. Here it says, using a ratio of 1 centimeters to 2 kilometers, how long would you draw a 6-kilometer line? Okay, so I've used the scale here, and I've drawn it out. 1 centimeter over 2 kilometers equals. Now my question is, where do I put my 6 kilometers? Well, the 6 kilometers is the real life length. So I put 6 kilometers up there, and I'm going to put x on the bottom. And now I can do my cross multiplying. I can say that 2x is equal to 6. So if I divide both sides by 2, then x is going to be equal to 3. And then my answer would be 3 centimeters. How did I know it's centimeters? Well, it's going to be the same unit as that one was in the numerator. On example number 2, it says using a ratio of 1 to 10, Using a ratio of 1 to 10, how long is a 3-inch line in real life? Okay, so the top is for my scale, and the bottom 10 is in real life. How long is a 3-inch line in real life? I think what they mean to say, this is a little bit unclear. If the 3-inch line shows up on the scale diagram, so if this is the scale diagram, how much is it in real life? In which case that we would put 3 inches up here, and then we would figure how many inches on the bottom. I'm kind of a guy who says, hey, I can see this pattern. I can say times 10 this way, so if I go times 10, it's 3 times 10 is going to be 30. But I think some of you might say, hey, come on, Mr. Speiser, I really like that cross-multiplying system. So if I go 1 times x, I get x equals 3 times 10. Hey, it's pretty easy, isn't it? I get 30. And again, just a reminder, when you say your answer, make sure you put the units. So it's going to be 30 inches. Here it says, using a ratio of 1 centimeter to 50 centimeters, how long would you draw a 2-meter line? So I think the 2 meters is going to be, this is the actual line, and then we would figure out what the scale is. Okay, so let's write this out. 1 centimeter to 50 centimeters. So the 2 meter is the actual, so that's going to go on the bottom. But we have a problem here. If I write 2 meters here, the problem is the units are different. I've got centimeters here, right, and then I just got meters there. So the problem I need to fix is, how do I change 2 meters to centimeters? So here's my question here. 2 meters is equal to how many centimeters? Well, if you have in your study guide, or if you just remember our metric quite well, here's like our meters, and then we had a gap here, and then we had centimeters, and then here were millimeters, and each time we did a jump, I think that gap is called decimeters, but we don't really have to know that. If we're going from centimeters to meters, or meters to centimeters, either way, it's 2 jumps. So we're going to end up being either multiplying by 100 or dividing by 100. So in this case, we're going from a larger unit to a smaller unit, so we're going to need more of them. So I'm going to be multiplying by 100, and when I multiply by 100, I'm really just adding zeros. So 2 meters is going to be the same thing as 200 centimeters. So I'm going to erase this business over here, and I'm going to say, hey, this is 200 centimeters. So there's something to note here, that when you're doing these proportions, that we have to have consistent units. If this is centimeters, this has to be centimeters. It's okay if the numerator and the denominator aren't the same, but the 2 denominators have to be the same, and then as a result the 2 numerators are the same. Okay, so how are we going to figure out this x here? I'll just make some space for myself. Well, if I do my cross multiplying, I'm going to get 50 times x, so that's 50x is going to be equal to 1 times 200, which is 200. At this point, I need to get x by itself. Since it's being multiplied by 50, I'm going to divide both sides by 50. 50x divided by 50 is just x. 200 divided by 50, if you use your calculator, it's going to end up being 4. So my answer would be 4 centimeters. And do I need to mention? Don't forget the units. Question number 4. If a line on a scale diagram is 5 centimeters and the actual line is 150 meters, what is the scale being used? Okay, this is a different question now. Here they give us, it's kind of like this. It's like they give us both of them on the right. On the previous questions, here was the scale, and on the right, one of them was unknown. Here they're giving both of them to us on the right. We're saying, okay, on the scale diagram, it's 5 centimeters. In actual life, it was 150 meters. What's the scale diagram? Well, remember before when I mentioned that on the scale diagrams, it's usually 1 centimeter and another something else. So I'm going to put 1 centimeter up here, and then I'm going to put x down there. So on these type of questions, when they want you to figure out what the scale is, put 1, either centimeter or inches, whatever it's being used, on the numerator, and really this is what you're going to be solving for, is that x. So since this is meters, I'm going to put meters over there as well. Okay, so we can do our cross multiplying. 5 times x is 5x is equal to 1 times 150, so that's 150. I'll divide both sides by 5. And now I get x is equal to, what is that, 30, and 30 meters. So my answer is, what is the scale being used? Here, again, there's 3 different ways to do it, but I'll say 1 centimeter for every 30 meters. That's one of the 3 ways you could do your scale. It depends how you like it. You could go 1 centimeter over 30 meters, or you could say, what was our last one? 1 centimeter equals, yeah, right, you could say 1 centimeter equals 30 meters. All right, we're almost done here. This is our last question. Here's a floor plan. It's drawn to a scale of 1 centimeter is equal to 2.5 meters. Find the area of the kitchen. Okay, so in my diagram, the kitchen's, it looks like there's some openings here for doors or something. I'm going to say that, I'm going to use that length and I'm going to use that length. So really what I'm going to do is find the area of this rectangle. Okay, so I'll tell you, if you don't recall, the area of a rectangle is equal to the length times the width. So what we have to do is get our ruler out and measure this side here. So if I measure from here to here, I think it's about 3 centimeters. We'll see how it photocopies, but that's what I get. And the other distance over here, I get about 2 centimeters for the width. Okay, but we don't want to find the area on the paper. We want to find the area of the actual kitchen. So the first step is we're going to say is that, okay, so if I'm, here I'll go back to blue here, if I'm 1 centimeter for every 2.5 meters, then looking at the length was 3 centimeters. What's the length in real life? Okay, so if I multiply this, I'm going to get x times, or x is going to be equal to 3 times 2.5, which is, I think, 7.5. So that's the length. How about the width? Well, the width we'll use the same scale, 2.5 meters, but it was 2 centimeters. So I get x is equal to, 1 times x is equal to 2 times 2.5. So I get the width is equal to 5 meters. So I can go back to my area here, and I could say, maybe I'll use black. My area is going to be equal to the length, which was 7.5 times 5. So that is 37.5. Now remember, I'm always saying about the units. So you would think that it's, I'll even write this down, it's 7.5 meters times 5 meters is equal to 37.5. Now it's not meters. When you're doing area, the units are always squared. Area units are squared. So it's going to be meters squared. And it kind of makes sense, because when you think about, like, if you do a meter times a meter, that'd be a square meter. That's how you figure out area, like how many of those square meters would take up the kitchen. Okay, so that is your last question. All right, I hope that helped, and make sure you do the worksheet, and when you've checked your answers for the worksheet, then come to me for a mastery check. Thank you very much.